Alrighty, here is your next lesson. Your next lesson is on convergent plate boundary. All right, please write this down. I'll be able to explain what happens at convergent plate boundaries and identify landforms that they create, including ocean trenches and mountains. Our launch for this is a deep trench is found in the ocean next to a chain of volcanic islands. How do you think, I'm sorry, what do you think is happening at this location? All right, so trenches. If we go back to our reference table on page number 12, we have some trenches. Like here we have an Aleutian Trench. All right, we have the Mariana Trench. Right, those are two of them that are well known. The Mariana Trench is the most well known one because that one is the deepest part of the ocean. Deepest part. All right, I have a video on Nearpod that you could check it. I'll do it now and see if we can try and get that up here so you guys can see. This was Challenger Deep, Nat Geo. All right, this is by James Cameron. James Cameron is the guy who directed the movie Titanic.
Empower your students to be more authentic, impactful writers with Grammarly's comprehensive AI
There you go,
writing assistance.
Grammarly. Yeah, okay. All right, anyway.
A National Geographic expedition is underway now. 250 miles southwest of the Pacific island of Guam. Almost 7 miles below the surface. Where one man will attempt to explore the least known and deepest place on Earth. A daring attempt that's been compared to landing the first human on the moon. National Geographic explorer James Cameron is embarking on a journey to the bottom of the Mariana Trench and back again.
National Geographic, as a society, believe in science and believe in exploration. They also actually believe in the underlying mission, which is to push back the boundaries of the known world, you know? And that's what this expedition is all about. The deep trenches, what they call the hadal depths, below the abyssal depths. Like if an abyss isn't deep enough, you can go to the hadal depths, are very poorly understood by science. They're really the last frontier of exploration here on planet Earth. We know very little about the species that live down there. We know very little about the distribution of the biological communities. We don't know how these animals have adapted to living under this unbelievable pressure that exists down there, 7 miles down at the bottom of the ocean.
All right, that's not what oh, this is what I want. Yeah, that's it. This is it right here. Okay. Titanic. Mount Everest invaded. Alright, that's how deep the Mariana Trench is. Alright, good. Nope, that's not what I want. All right, and that's happening because we have plates that come together. So this is your picture on page 11 of your reference table. All right, as one plate is getting pushed downward into the mantle, the other plate that it's colliding with gets pushed up. But there's going to be a point where the two plates will meet at the surface. And it produces like this little wedge. I wouldn't say little because it's pretty big in some areas. But it produces a wedge of a lower depth in the ocean. And that is called your trench. And that's how trenches are made. They're made when two plates come together. One plate moves underneath the other. And it produces this wedge which has a lower or a deeper depth in the ocean. All right, there you go. All right, convergent plate boundary occurs when two tectonic plates move toward each other. Right, they have to move toward each other. And when they move toward each other, we can see that it forms a lot of good stuff here. As this plate moves down into the mantle, we can see that this plate kind of like disappears, but it doesn't disappear. Matter cannot be created nor destroyed, but this becomes part of the mantle now. And we can see that some of this, right, will begin to turn into magma. Right? And magma is liquid rock, and that can rise to the surface. All right, so when plates come together, you can form mountain chains, right? So the land masses will buckle upwards. They can get uplifted, they can move up, they can buckle and produce these mountains. And there's going to be times in which these mountains are volcanically active from the plate that's moving down into the mantle. All right, we have three forms of convergent plate boundary. First one is called oceanic continental. All right, during this collision, the denser oceanic plate subducts beneath the lighter continental plate. Nope, that's not it. Nope. Where is it? Here, reference table. This, yep, okay. All right, we went over this together. Oceanic crust, 3.0 grams per centimeter cubed. Continental crust ranges from 2.7 to 2.9 grams per centimeter cubed. So the oceanic crust is more dense than the continental crust. All right, the word subduction or subduct is the downward movement of the plate in the mantle. All right, pause at any time if I'm going too fast. All right, next one is oceanic. During this collision, the older, denser oceanic plate subducts beneath the younger, less dense crust. So they both have the same densities, 3, all right, but newer oceanic crust might be less dense than your older one. Your older rock is going to be cooler or much cooler, which makes it contract more between the molecules. You're also going to get, some water buildup in this rock that can add more mass, making it denser, right, than newer rock that's being made and produced. All right, so we see that one of these plates here, this oceanic crust, right, since this is subducting going down, this plate here, right, has to be moving to the right. This plate over here has to be moving to the left. This plate will move underneath the other, and this will still produce an oceanic trench, that nice wedge that's there, deep or deeper part of the ocean. All right, going back to the previous slide. All right, we have another trench that's here. It's kind of a little hard to see here, but you have your trench between these two plates. As the subducting plate goes down, pressure builds up, temperature builds up. This rock mass will eventually get destroyed and be part of the mantle. And in that process, if the rock becomes too hot, it can definitely turn into molten rock magma, rise to the surface, and build your volcanoes up, getting higher and higher and higher and higher, and eventually can make it above sea level. All right, this is oceanic collision. All right, check this out. It's over here on this side. Yep, here it is. Okay. So the Japanese islands, there's 5 major islands of Japan. I think it's 4 here. All right, but there should be 5 islands of Japan. I believe it's 5. Here's 1, 2, 3, and 4. All right, this Japan is sitting on a portion of an oceanic plate, or a portion of the plate that's going to be oceanic. And the Pacific plate, of course, is all oceanic. And when oceanic crust meets oceanic crust, the more denser one will begin to move underneath the other. In this case, right, the Pacific plate will be moving underneath the Eurasian plate. Now the one here in white for Japan, right, is part of the Eurasian plate. That's here. Which can make the mountains occur and making this volcanically active too. All right, last one, continental. So this one, for there might be some subduction, but nothing substantial. It's something that you're just gonna have to just memorize at this point. All right, they both consist of the same densities, but we have the word here buoyant. Right, when you hear the word buoyant in water terms, buoyant means floating. All right, so these crusts, even though they do collide, one will rise above the other a bit more, giving you a mountainous landscape or mountain chains that can be made. Right, there will be no significant subduction into the mantle, so these will lack volcanic activity. All right, so during this collision, neither plate subducts significantly because both plates are too buoyant. The crust crumbles and it is pushed upward. And these are the ones that give you the biggest mountain chains in the world. All right, and one of those is when India. All right, let's go back. we go. So during Pangea, all right, India was somewhere down here in the southern portion or the southern hemisphere. India, when it broke apart, here's India, a little bit more visible. India moved northward. Here's India again. And collided with Asia, giving you the biggest and tallest mountain chains in the world, the Himalayas. Right, that's a continental collision between two land masses. Now, India is, even though India is surrounded by water, right? India is it has continental crust for that landmass. Asia, right? Parts of Asia can be oceanic. Some parts are continental, but it turned out that when they collided, we had two continental portions of the plates colliding. All right, we have some processes. We have subduction. Subduction, the process where one tectonic plate sinks beneath another into the mantle. Opposite of subduction is uplift. The upward movement of the Earth's crust, often caused by tectonic forces. All right, I'm going to hold it off right there. All right, I'm not going to go into 3 and 4 yet. I want to show this to you. Nope, hold on. This part. All right, so this is on your key down below page number 12. We have a subducting plate and we have the overriding plate. Now, the overriding plate is the plate that is getting uplifted, right? That's your uplifting plate. So one plate will usually go underneath the other. All right, and this reminds me of a cold front with the triangles. All right, so behind your triangles would be the plate that is moving underneath the other, the subducting plate. And the triangles are pointing toward the plate that is going to be rising upward. Right, that's going to be your plate that gets uplifted, right? Or the overriding plate. All right. So good example. If I'm going back to Japan and this portion of Japan, because this portion of Japan is the Philippine plate. All right, I'll just do this portion first. So the Pacific plate is converging with the Eurasian plate. Since the triangles are pointing toward Japan, and wherever the triangles are pointing to would be your uplifting plate. So Japan is getting uplifted toward the surface, and the Pacific plate is going to be moving underneath the Eurasian plate at that point, giving you these volcanic islands in the ocean, known as Japan. And part of Japan is over here also interacting with the Philippine plate. So the Philippine plate is having convergence with the Eurasian plate. The triangles are still pointing toward Japan, so that's going to be your overriding plate or the uplifting plate. And this portion of the Philippine plate is moving underneath Japan, making it volcanically active. All right, here we go. Number 3 is melting and volcanism, right? So when rocks melt, they're in liquid form. It's called magma. Magma will rise to the surface. It's less dense, and that can make the surface volcanically active. Last one, of course, earthquakes. Right? Earthquakes always a major concern. We can have earthquakes on land, earthquakes in the ocean. If earthquakes happen in the ocean, that's even a bigger concern because that is going to be the case for tsunamis. All right, some more topographic features. We have trench and oceanic trench. All right, a deep, narrow depression in the ocean floor form where one plate subducts beneath the other. All right, and those can form your trenches or your oceanic trenches. All right, your archipelago, your volcanic island arcs. All right, this is a group or chain of islands clustered together, series of islands being clustered together in a sea or ocean, and they're volcanically active. All right, number 3, you can form your mountain ranges on land. All right, your volcanic island arcs can also be found, good portions of these, in Southeast Asia. All right, here we go. Yeah, a lot of convergence here in Southeast Asia. All right, now we'll produce your series of islands, right, volcanically active. Some of these have, historically speaking, the biggest and loudest volcanic eruptions in history. You have, there's Sumatra, there's Krakatoa. Krakatoa, I mean, if you've done your research before, Krakatoa, I think in the mid 1800s, also caused a tsunami to happen too. And that eruption happened on land. Yeah. All right. Let's all right, and that's it for that portion. All right. That concludes this lesson on converging plate boundaries. So you can go on to Nearpod. I'll give the link there. You can rewatch the video if you want to. You can answer a few questions, and then you can roll into the next lesson. All right. Thank you, and have a good day.